Hi, and welcome to a review of the New York State Chemistry Regents exam, specifically the January 2025 Part B-2. All four parts of this Regents exam I'm putting together as really an ultimate review for the Chemistry Regents. In order to just pass this exam, you have to get 50 points out of a possible 85. The multiple choice sections, Part A and B-1, I've already done in separate videos. If you haven't checked those out and you want to start from the beginning, I'm going to go ahead and put a link up here in the right-hand corner. I also have in the description for Part a set of review sheets on my website that you can go ahead and download for free. There is no reason you can't pass this exam. In fact, there's no reason you can't crush this exam, but you got to put some work in. Now, Part B-2 here is 15 questions. If you are a borderline student and looking just to pass the Regents exam, I'm going to think you're going to need to at least get 5 out of the 15 here right. And it is possible. I don't want you to think it's impossible. That is not the case. But I'm glad you're here. I'm hoping that you follow along, maybe even do these questions first. You can find them just by Googling New York State Chemistry Regents exams and then come on back. We're also going to go through some tricks and tips as I explain these questions. With that, let's check out question 51. Right off the bat, I have to make sure you understand when you have a question and it tells you to state it in terms of, use those words in your answer. Now, you don't have to go really more than one sentence here, but however you're going to explain it, the key is to make sure you use those words, because there have been many times where my students, they say something that is totally right, but they didn't talk about it in terms of what the question was asking about. And here, how the light emitted by an excited boron atom is produced, we're going to go ahead and explain that with electrons and energy states. An excited boron atom has absorbed energy, moving electrons into higher energy states. Those higher energy states, now strike that, the electrons in those higher energy states, those electrons in those higher energy states now drop back down to lower energy states and emit light. That's really all you have to say. That the electrons, when they're in the excited state, they're going to go ahead and drop back down to lower energy states and emit light. On to 52 and 53. Here is our first math question. And typical chemistry regents, we're not even calculating the answer. All we have to do, as it says here, is show a numerical setup. In other words, we're going to go ahead and show the numbers in a formula, and that will suffice as our answer. Now, you're thinking, oh, numbers, I'll go to reference table T. There is no formula listed on reference table T for calculating atomic mass. Atomic mass is what we call a weighted average. So we have to take into account the natural abundance. How many times out of 100, for example, these different isotopes show up in nature. And it is not 50-50. So it's not like an average you normally would take where you add up the numbers and then divide by however many numbers you added up. Instead, what you're going to do is you're going to get mad. And that is just for short for multiply, add, and divide. What are you going to multiply? You're going to multiply your atomic mass by your natural abundance. Now, you have to write this out. This would be on your answer sheet. So your 62.93 times your 69.15. Now, you got to do that also for the second isotope, and that is your 64.93 times your 30.85. The A means add. We're going to put a plus sign because after they're multiplied, they would be added together. And then the D is for divide, and we're going to divide by 100. So that is a correct numerical setup for 52. For 53, a technician determined the percent natural abundance of copper 65 in a sample to be 31.47%. Determine the percent error for this percent natural abundance of the copper 65 compared to the accepted value shown in the table. So obviously this is the table. Here is that accepted value. Now let's go to the reference tables because I do want to show you something here. Okay, you can clearly see percent error. It is slightly different than percent composition. Percent composition is the part over the whole times 10. Percent error, we have that measured value that was given in the question, the accepted value, that's the one on the table, and we're going to go ahead and then calculate a percent error. Now, I know it's weird. In 52, we had to show the numerical setup. In 53, all they're looking for is the actual answer. But if I was you, I would have the reference table T open and put the numbers maybe right on the reference table, because remember, you're going to be given a reference table. You can write all over it or put it here on the paper and then use your calculator and calculate your answer. Well, percent error. So I'm just going to show you here percent error, right? We have the measured, let me go back, measured value minus accepted divided by accepted. So the measured value is my 31.47 minus the 30.85 over the 30.85, because that's accepted, times 100. I'm running out of room here, but that's okay. And literally take out your calculator right now and calculate an answer. You know, you don't want to look at this and just say, yeah, I got it. No, you don't have it until you actually do the calculation. And I'm going to do the same here. 31.47 minus 30.85, and then 0.62 divided by 30.85, and multiply by 100, and the percent error is 2%. Okay. Also, before I leave this, remember these are in parentheses. Make sure you do your subtraction first. All right, we are looking at 54 through 56. It says the elements beryllium, magnesium, calcium, strontium, and barium are located in group 2 on the periodic table. These group 2 elements have both similarities and differences in their physical and chemical properties. 54. Based on the location of group 2 elements on the periodic table, state the element classification of these elements. All right. Based on the location, state the element classification of these elements. Well, we got to remember it's beryllium, magnesium, calcium, strontium, and barium. And we are going to go to the periodic table. All right, we're at the periodic table. We're dealing with beryllium, magnesium, calcium, strontium, barium. Well, you're given the words for the elements, right? The element names and not the symbols. The periodic table just gives you the symbols. Keep in mind during the whole test that you have reference table S at your fingertips. If you ever forget a name or a symbol or a name, it's here. All right, if we go back, all we're going to do is just circle them, and here they are. And lo and behold, they're in group 2. And of course, because they're group 2 metals, they are known as the alkaline earth metals. I just wrote it here. You would write it on your answer paper. Don't confuse the alkaline earth metals with the group 1 metals that are the alkali metals. The way I always remembered it, alkali is 1 word, alkaline earth is 2. Alkali is group 1, alkaline earth group 2. For question 55, explain in terms of, again, electron shells, why the atomic radius of a calcium atom in the ground state is greater than the atomic radius of a magnesium atom in the ground state. Back to the periodic table. Well, we're comparing calcium and magnesium. I'm just going to circle them. And lo and behold, calcium is larger than magnesium in the ground state because calcium has 4 energy levels and magnesium only has 3, right? These numbers at the bottom of each of these squares of these elements on this periodic table give us what's known as the electron configuration, the layout of electrons in an atom. Electrons, remember, are on the outside of the nucleus. They are going to then be directly related to the size. Just make sure you're answering the question. You can pretty much say it whatever way you need to, but just make sure you do it, and you really don't have to answer more than one sentence for these questions. Let's go to 56. State the general trend in first ionization energy for the group 2 elements, beryllium through barium, as these elements are considered in order of increasing atomic number. Well, back to the table we go. We're checking out group 2, looking at what happens to ionization energy as we go down this column. We're going to look at some of the values on reference table S. It's very interesting because you really don't need to know what ionization energy is to get to the answer. As we go down the group and atomic numbers increasing, the ionization energy is decreasing. You can see that here. And you could add those other couple of elements too. Ionization energy is the energy required to knock out an outermost electron of an atom in the gas state. So as you go down a group, typically the numbers get smaller because the valence electrons are further and further from the nucleus, so they're easier to knock away from the nucleus. But you didn't need to know all that. You just needed to know to look it up on reference table S. We are checking out now 57 through 59. Here we have 2 different gases, nitrogen and oxygen, in separate sealed rigid containers with a movable piston. For 57, we're asked, compare the average kinetic energy of the gas molecules in diagram 1 to the average kinetic energy of the gas molecules in diagram 2. There is nothing hard about this question. You just have to remember average kinetic energy is temperature, or it's not temperature, but it's directly related to temperature. And in this case, since both gases are at the same temperature, they both have the same average kinetic energy. For 58, determine the volume of O2 in diagram 2 when the conditions are changed to STP. Here we're going to use the combined gas law to answer this question. We have pressure, volume, and temperature to start. STP means standard temperature and pressure. I'm going to show you where that is. I'm going to show you where the combined gas law equation is, and we're determining the volume, which means we're getting to the answer. It's not just the setup. Reference table A, the front of the reference tables, and here's your standard pressure and temperature. You have to make sure when you're dealing with the combined gas law, temperature always has to be in Kelvin when you're doing your calculations. So just don't let them trick you. If they give you Celsius, we have to change it to Kelvin. And then your pressure can be either kilopascals or ATM. That's going to depend on what other numbers you're given. Just be consistent on both sides of the equal sign. Here is your combined gas law right here. Pressure times volume divided by temperature equal to pressure times volume divided by temperature. Let me show you the setup. Okay, I put the setup here, right? So 60 kilopascals, 300 Kelvin was the pressure and the temperature respectively. The volume was 1.8 liters. Now on the right-hand side, 101.3 kilopascals. I have to use that. I can't use ATM. I can't mix and match. 273 is my Kelvin. Now I need to solve for X. My students, right before I retired, they were having a tough time with this. I'm not really sure why, but we're going to just cross multiply and divide in order to get the answer. I think that's the easiest way to do it, which means, of course, we're going to do, all right, for 58, when you cross multiply and divide, you should get an answer of 0.97. You don't even need to put the unit. The unit's usually on the answer booklet or in the answer booklet, but 0.97 is your answer. If you're not getting that, go back and check your calculations. Don't skip this as you're practicing and not do the calculation to make sure you got it. With that, 59, it says determine the pressure in atmospheres of the nitrogen gas in diagram 1. This is an interesting and I'm going to say new type of question, a new question that we don't normally come across. In order to do this, we just need to set up a proportion. We know from STP, right, the values on table A, that 1 ATM is equal to 101.3 kilopascals. And that's why I can set them up in a fraction, because it's the same thing over the same thing. All right, well, I don't have 101.3 kilopascals for the nitrogen gas in diagram 1. I have 60. So how many ATM would that be? So it's X ATM divided by 60. Now we know it's going to be less because the kilopascals are less. So keep that in mind too when you're doing your calculations. If you can predict where the answer is going to lie, that's important, because then if you mess something up with the calculator, you can fix it. Again, we're going to cross multiply and divide here. It's 101.3 times X is equal to 60 times 1. I got to get X alone. In other words, 60 divided by 101.3, and my answer here is 0.59 ATM. We are through 10 questions, 5 more to go. Questions 60 through 62. Boiling point for a sample of a molecular compound is 80 degrees Celsius, the standard pressure. Heat of fusion is 127 joules per gram. Question 60. Compare the potential energy of the molecules in the sample before vaporization to the potential energy after. Well, heat of fusion, even though they give us this, heat of fusion is from a solid to a liquid. Vaporization is going to be from a liquid to a gas. And what do we know about that? We know that the potential energy is going to increase, or the potential energy after vaporization is higher than before. For me, it kind of sounds like, or it seems like an odd question, but that's all you have to say. For 61, determine the amount of heat required to completely melt 50-gram sample of this molecular compound at its melting point. Well, we're given the heat of fusion, and we are given the mass. There are the heat equations on reference table T. Let me show them to you. Back at reference table T, here is my equation. M times H sub F is equal to Q. My mass of sample is 50. My heat of fusion was given as 127 joules per gram. So it's just 50 times 127, and my answer is 6,350 joules. Finally, for 62, it says explain in terms of intermolecular forces why the boiling point of this molecular compound is lower than the boiling point for water at standard pressure. So intermolecular forces, this is the attraction between the molecules that make up a substance. If the boiling point of this molecular compound is lower than the boiling point of water at standard pressure, it means water boils at 100 degrees Celsius. This is boiling somewhere below. If it boils at a lower temperature, it means the intermolecular forces are weaker for this compound than for water. And that's all you have to say. We're looking at the last three questions here for part B1. Identify the positive ion in the sample of HCl solution. This is hydrochloric acid. There's actually an acid table, a list of common acids and a list of common bases on the reference tables, and HCl is one of them. When you see AQ, of course, it means it's in water, and what happens is acids ionize, and the only positive ion as a result is going to be H+, right, or the hydrogen ion. For 64, based on table M, state the color of litmus when placed in a sample of the original HCl solution. If we go up here, it says a sodium hydroxide solution and an acid-base indicator are used to determine the molarity. All right, so we're starting with 15 mils of HCl. But we don't know what the concentration is, but we don't have to give a pH value. All we have to do is state the color. So let's go to table M. Since we're starting with an acid, our pH is going to be low. And for litmus, the low end is going to be red. Finally, for 65, using the titration data, determine the concentration of the HCl solution. Here we're going to use the titration equation on reference table T. We are at table T, and let's scroll down, and here is the titration equation. All right, I rewrote it. I like to put and label the acid and then label the base. And let's go back to the original couple of sentences here. We have a 15 milliliter sample of HCl, so that volume is 15. We're looking for the molarity of the HCl, that's our Ma or our X. The molarity of the base is 0.01 and the volume is 30. All we have to do now, 0.01, 0.01 times 30. We should know this, it's just 0.3, and we're going to divide that by 15, and our answer is 0.02. So again, we're not showing just the setup, we're determining, which means we're getting to the answer. 0.02 is the answer. Remember, we were looking for 5 easy questions here to make sure that at least a student will be able to pass the exam. So let's just run through that very quickly. Starting from 51, let's kind of scroll down here. I think 54 is a totally doable question, right? The location of the group 2 elements. You have to just remember, it's a fact, the group 2 elements are known as the alkaline earth metals. Then I also think that 56 is really easy because you're dealing with ionization energy for group 2 as you increase in atomic number, meaning going down the group, and all you have to do is go to table S and look up the values. And really, for that matter, 55 is easy because if you know to look at the periodic table, you're going to see that the number of electron shells for calcium is more than it is for magnesium. So those questions are fairly easy. Let's find a few more. 57 is extremely easy if you remember that a measure of average kinetic energy is temperature. That's one of those definitions that you need to know, making this an extremely easy question as long as you know that. For question 60, comparing potential energy of molecules before vaporization and then after vaporization, I think it's self-explanatory that you got the liquid phase, they're closer together, less potential energy than when you're in, or what, not you, but when the molecules of this sample are in the gas phase. And then finally here, if you can't remember after taking a year of chemistry that HCl, that are known as hydrochloric acid, your positive ion is not, is going to be your H plus. If you can't remember that, yeah, that's pretty tough. That's just totally straightforward. 64 isn't really bad either because you're starting with an acidic sample. You know the pH is going to be low. You don't have to go crazy and get an actual number, but just know when you look at the table, the acid side is going to be red. With that, we're done with B-2 here. We got part C to go. I will be getting that out soon. If it's not out when you go ahead and do your review and check this out. I got tons of shorts and other videos. You can check out other Regents exams and look for explanations. Look for reviews for specific sections of the course if you need that. Whatever you need, I have it on my channel. I hope you take advantage of it. And no matter what, good luck.